Okay, Assalamualaikum everyone. Welcome back. So now we are going to enter new chapter, which is chapter 6, related to the fatty alcohol. So this chapter will be covered about 2 weeks. So we're going to finish this chapter by 2 weeks. Okay, so what is actually the fatty alcohol topics? First, we are going to study in terms of their productions of fatty alcohols and also its derivative. And then we will study on how we produce our fatty alcohols and through the flow charts. And lastly, we are going to learn about its uses and their applications. Okay. So the outcomes of today learning is first we are able to define what is the fatty alcohols and also to describe their production process of fatty alcohols. And we will cover these new two things today. So this is the flowcharts of our products, our oleochemicals. So started from the raw material, which is our oil and fats, or we call it as the triglycerides. And then from your raw material, we go to the basic oleochemicals. So we already cover on your fatty acids. Now for today, we are going to cover on the fatty alcohols, and after that, the fatty acid methyl ester. So the directions of the productions of fatty alcohol started from your oil and fats to the fatty acids and also to the fatty acid methyl ester, and both of them will give products of your fatty alcohols. So after you obtain the fatty alcohol, we can make more products, which we call as the derivative here. Such as the Gerbex alcohol, alkyl chlorides, fatty alcohol ethoxylates, fatty alcohol sulfates, technical ester, and also the alkyl polyglycosides. And this product can be further derived into other product depending on its applications. Okay, this is the view for all products of the oleochemicals. So here the productions of your fatty alcohol here. Okay, we can start from your palm oil and fats. Okay, to your fatty ester, and then the distilled fatty ester, and go to the hydrogenations, and we will obtain our fatty alcohols. Okay, here it doesn't show the direction from the fatty acid, but we have two directions of your fatty alcohol. As you can remember from here, it is from fatty ester and also fatty acids. Okay, let's see the compositions of the fatty alcohols. So fatty alcohol actually is a fat with your alcohol. So alcohol usually we represent by OH here. So you can see there are OH functional group which attached to the long carbon chain. So fatty alcohols or long chain alcohols are usually high molecular weights, straight chain primary alcohols. So of course, the higher the number of carbon atoms, so it will contribute to high molecular weights. And also the change is the straight change, which is the saturated of alcohol can be saturated, but can also range. So the number of carbon atom can be few or can be many. So as few as 4 to 6 carbon and many as 22 to 26 carbons. So which can be derived from your natural fats and oils. So the precise chain length varies with the sources of your oil. So this is the general balance of your fatty alcohol. So you can see here the number of carbon atom here. So it's N. So depending on the number, of total carbons. And also it is a straight chain saturated with at the ends of the chain is the alcohol functional group OH. Okay, let's see the flow charts and productions of your fatty alcohols from fatty ester. Okay, here from your fatty fats and oil, from the process of the transesterification, we will obtain our fatty ester. So from our fatty ester, it will go the hydrogenation process to produce your fatty alcohols. On the other hand, your fat splitting process will obtain your fatty acids, and from your fatty acids, it will go hydrogenation process to produce your fatty alcohol here. Okay, so next is the derivatives of the products. Okay, so the chemical equations for the production. So first, this is your triglyceride, oil and fats, which have C double bond O and the alkyl group here. So it will react with your alcohol, methanol, to obtain the fatty ester and glycerin. So we will have C double bond O, O, and the alkyl group. So we have the methyl ester or fatty methyl ethyl ester. So your methyl ester will go the hydrogenation process. So we require 2 hydrogen here with the help of the catalyst. So it will produce your fatty alcohol and the methanol. So it will break your C double bond OO here. C double bond OO by the additions of H. So we will produce your alcohol and also the methanol, fatty alcohol and methanol. So one of the methyl group will go to the methanol, the others will go as the fatty alcohols. Okay, so the productions of fatty alcohols, there are even though there are only one process of the productions of fatty alcohol, we call it as the hydrogenation. So there are 2 ways: direct hydrogenations of fats and oils, or second, the catalytic hydrogenations of your fatty acid or fatty esters from fats and oil. But usually it is your catalytic hydrogenation, it is usually not commercial, and there will be some loss of the glycerin. It require high consumptions of hydrogen and high amount of the catalyst. This one is not commercialized, but in our cases we will study this method, the catalytic hydrogenations. Okay, so catalytic hydrogenations of your fatty acids and methyl ester can produce your fatty alcohols. So here we have the fatty acid equation: C double bond OOH for carboxylic acid. Addition with the hydrogen will produce the fatty alcohols and water. The difference with the fatty ester is you will produce the methanol here and the fatty alcohol. But for fatty acid, you will produce the water and also the fatty alcohol. So both of the process require catalyst. Here, example given is copper chromium. What is the difference between these methods? So both of them use hydrogen, but their products and the raw material used. Since for the fatty acid, it is a carboxylic acid, so it involves of the acid. So the designs of the equipment need to consider the corrosion resistance as compared to PEM do not require corrosion resistance. And also the process require high temperature, but the lower yield. And there will be the damage of catalyst because of the uses of the fatty acid, which is very acidic. On the other hand, for your flame, it require lower temperature and lower pressure. And for fatty acid, high pressure. Okay, so the direct hydrogenation of fatty acid not used in the large commercial scale. And acid resistant catalyst is not required, so the same thing. Okay, the direct hydrogenations of fatty acid not used in a large commercial scale. Okay, so the hydrogenation process from your fatty ester is usually a high pressure. And this is an example of the catalyst used, copper chromate and zinc chromate. And then if you use copper chromate, you will produce saturated fatty alcohol. Zinc chromate, unsaturated fatty alcohol. This is the reaction temperature and pressure, and the reactor use tubular column. Temperature is high up to 300, pressure 30 bar, 30 kilopascal. Okay, there are two methods of the hydrogenations for the fatty ester here. We have the fixed bed process or suspension process, where both of these processes are dependent on the catalyst used. Okay, the high pressure hydrogenation using fixed bed process. So fixed bed means that catalysts are fixed as bed and support on carrier. So the process here, your fatty ester will enter the heater. It will go for the heater first, preheat your fatty ester and your excess hydrogen. Okay, we will preheat here and then go to your reactor. And this is the reaction temperature, pressure, and the residence time 5 minutes. Okay, and then it will go to the separator and we will get your fatty alcohol and also the methanol. So we need to separate the remaining hydrogen here, where it can be used as the recycled hydrogen, to the process and the fatty alcohol. Okay, so high pressure hydrogenation using fixed bed is the operating conditions are comparatively mild, and the fatty alcohol produced does not require further processing. Okay, the yield is almost 99%. The hydrocarbon and unreacted ester is less 1%, and the catalyst consumption is claimed to be less 0.3. Okay, that's all for today. We will continue next chapter later. Thank you.